Yes. Now, after uni holidays, now before holidays, we started functions. Functions also, we discussed few different types of functions and its graph. Also from the graph, we can make it out the domain and range of a function from the graph. That also we discussed. Now, those few typical functions and its graph, we discussed the modulus functions, which is p-shape, the greatest integer function, which goes like step by step. Then the signum function with one line, then zero, again dot, again from those broken lines. Again, these questions and graph, it may not be asked in your examination, but those who go for higher studies, you should know these things. Similarly, we will discuss about two more functions, which is in your syllabus, but not in textbook. They are logarithmic and exponential functions. So write that down. Logarithmic and exponential functions. Logarithmic and exponential functions. Write the definition, then you will get the idea. If n is equal to a raised to b, if n is equal to a raised to b, you will write right. This is the exponential form. Exponential form. N is equal to a raised to b. Even we write, we know how to write in exponents. A 2 cube, 2 square, x square. These are all in the exponential form. Then the corresponding logarithmic form, we write log n to the base a is equal to. This is the logarithmic form. Logarithmic form. So the exponential form and logarithmic form. Example, we know 8 is equal to 2 cube. Then we write log 8 to the base 2 is equal to 3. Log 8 to the base 2 is equal to 3. So you should know how to change the exponential form to logarithmic form and also logarithmic form to exponential form. See, 2 cube is 8, then log 8 to the base 2 is 3. It is not new chapter. One of you asked a doubt, is it a new chapter? No, it is not a new chapter, it is a continuation of functions. We are discussing about functions. These are two special type of functions, which is in your syllabus, but not in textbook. That is what I said. So log n is equal to 2 cube. Again, being science students, you know what is logarithm, because in physics and chemistry, you use logarithm for calculations. You take logarithm for calculation. One of you wrote you didn't understand logarithm. What is to understand? The definition I gave, if n is equal to a raised to b, then its logarithmic form is log n to the base a is b. Example, 8 can be written as 2 cube. Then we write logarithm of 8 to the base 2 is equal to 3. What to understand? That's the definition. That's the definition of log. Now, another doubt. How to read the log? This is how to log 8 is written as log 8 to the base 2 is equal to 3. That is how to read it. That is how to read it. Similarly here, we read log n to the base 8 is equal to b. So this is how to write the exponential form in logarithmic form. Or if you are writing log p to the base q is equal to 1. This is logarithmic form. How to change it back to exponential form? See, 2q is log 8 to the base 2. So this will be how to write p is equal to q raised to r. See that in both the cases, in logarithmic form as well as the exponential form, the base remains the same. You know that for the exponential form, when we write a raised to b, this a is called the base and b is the exponent or power, exponent. So base remains the same for both logarithmic function as well as exponential function. See, base is a, here also base is a. So n is equal to a raised to b log n to the base a is b. That is two different form, exponential form and logarithmic form. And this is how to convert the exponential form to logarithmic form and logarithmic form to exponential form. Next one. So next one is see logarithmic form also. Both logarithmic form and exponential form. We have two texts. The natural logarithm and common logarithm. Similarly, natural exponential form and common exponential form. Especially in logarithmic form, we use it natural logarithm and exponential logarithm. See, natural and common logarithm. Natural logarithm and common logarithm. Before that, write this one. E is an irrational number. E is an irrational number. E is an irrational number. Its value lies between 2 and 3. Its value lies between 2 and 3. See, you know pi is an irrational number, pi. Its value, its nearest value, approximate value in decimal form, actually irrational numbers, we cannot write that in a certain fraction. Even though we used to write pi as 22 by 7, it is not 22 by 7. It is not 22 by 7. Yes, Shashank, you are right. I'll come to it. The value of pi is not 22 by 7. It's an approximate value taken for calculation. It is 3.1412. It goes on. And lakhs of places are there. It is a non-terminating and non-recurring number. Similarly, this E is also a non-terminating and non-recurring decimal number. Its value you can search in net also. It is 2.718. It goes on. 2.71 something. It goes on. The value of E is 1 plus 1 by 1 plus 1 by 1 into 2, 1 by 1 into 2 into 3, etc. If you are, it goes on. Next one is 1 by 1 into 2 into 3 into 4. Next is 1 by, that means after each step you can see the number becomes smaller and smaller and smaller and it goes nearly equal to 0. It's an infinite series. If you are calculating this one, its value comes nearly 2.718 something, it goes on. This is the value of E. Now, the next one, exponential function. Exponential function Write it. Exponential function with base 10. With base 10. Are common exponential function. Are common exponential function. With base E is natural exponential function. With base E is natural exponential function. Similarly, see the exponential function with base 10. The exponential function with base 10 is the common exponential function, and with base E is natural exponential function. Similarly, see how did I write similarly? 3 lines R and Y. Similarly, logarithmic function with base 10. Logarithmic function with base 10 is logarithmic function with base 10 is common logarithm, and base E is natural logarithm. So we have the common logarithm and natural logarithm. Common logarithm and natural logarithm. Let me take the attendance. One of you can you repeat the second point without the short forms? Short forms I wrote logarithmic function. This is logarithmic function. I wrote log fn, logarithmic function. So remember it, with base 10, whether it is exponential function or logarithmic function, with base 10, we call it as common exponential and common logarithmic. If base is E, they are called natural functions. Natural means natural exponential function or natural logarithmic function. In physics and chemistry, for calculations, you may have used log. Even in your record books, the last page you can see log is printed. Log is printed. Those log are common logarithms, that is base 10. So in physics and chemistry, you use common logarithms. Whereas in our study, in maths, when we consider functions, we always take the natural logarithm or logarithm with base E. Logarithm with base E. Now, so, and also remember that Whenever in math, while writing functions, everywhere we never write the base. We write log x only. Sometimes we write f of x. Function f of x is equal to log x. See that whenever a function is given, logarithmic function is given, if base is not written, that means there is that invisible base e. That means if base is e, usually we don't specify that e, like positive, negative numbers. Negative numbers we write -2, -3, etc. These are negative numbers. Whereas by writing positive numbers, we write only 2, 3, etc. 2 means that 2 is positive. So if it is positive, we will not particularly specify that plus sign. It is understood. Whereas negative, we have to specify. Similarly, square root also. Taking root, if it is cube root, we write cube root of x. Cube root. Whereas square root of x, actually, when we write square root, there is a 2 here. But generally, we don't write that. So in that radical sign, if you are not writing the index, we call it as index. That means it is understood index is 2. Index is 2. So in radical sign, if index is 2, generally we don't mention it. With positive numbers, if the numbers are positive, generally we don't put that plus sign. So is for logarithmic function. Logarithmic function, if base is e, generally we don't write e. Even if you are writing it is not wrong, but generally we don't write e. So whenever you see logarithm without a base, whenever we see a logarithm without a base, see that the base is already e. Base is e. If base is e, then we don't specify it, it is log. It is with base e. And the value of e also we discussed. Now, next one. Next one, we discuss the domain, just write this down. Write this. Domain. Domain of exponential function. Domain of exponential function. Domain of exponential function is R. Range is set of all positive numbers. Set of all positive numbers. See, why set of all positive? See, we discussed 2 exponential functions with base 10 and base 8. Whatever it may be. See, base 10. If you are writing 10 raised to anything, 10 raised to x. This is the common exponential function. See, this 10 raised to x, if y is equal to 10 raised to x, you can see this x, the value of x is a domain, value of y is range. This x can be any real number. X can be positive, x can be 0, x can be negative, or even any fractions, no problem. But the value of y will never be negative. It is always set of all positive numbers. It cannot be 0 also, because 10 raised to something. See, if 10 raised to 0, if x is 0, 10 raised to 0, we know that 10 raised to 0 is 1. Any number raised to power 0 is 1. And if a positive number, 10 square, 10 cube, 10 raised to 5, whatever it may be, for any positive number, you can see y remains as positive. Now, if this exponent is negative, for example, 10 raised to minus 2, y is equal to 10 raised to minus 2. The value of 10 raised to minus 2, will it be negative? No, it cannot be negative. Why? Because 10 raised to minus 2 means 1 by 10 square, which is 1 by 100, still it remains as positive. That is why the domain of exponential function is always R, whereas the range is set of all positive numbers. Next one. Similarly, you can think about domain of logarithmic function. Domain of logarithmic function. Domain of logarithmic function is set of positive numbers. Domain of logarithmic function is set of positive numbers and range is R. Range is R. Range is R. See that this domain and range gets interchanged. Next year you will learn this in detail. Domain of logarithmic function is set of positive numbers. Okay, Yusuf asked a question. What if you take minus 10 raised to 3? We are talking about natural logarithms. Natural logarithms are natural exponential function. Natural, similarly, common logarithm and common exponential function. We discussed, I have shown the example with common exponential function. With common exponential function, the base is always 10. For natural exponential function, base is 2.7. We are discussing about only this common exponential function. You asked minus 10 raised to 3. Minus 10, it is not common exponential function or natural, it is with a different base. We discuss about only this common exponential function, natural exponential function. Okay, you got it. So this one, its domain and range are interchanged. That means domain of logarithmic function is set of all positive numbers, and range of exponential function is range of logarithmic function is R, set of real numbers R. See that this domain and range are interchanged. You will learn this in detail in next year. These are called inverse function. For the time being, just draw this graph also. Just draw this graph. And you will write one observation also. This is -1, this is 1. Clearly, this one may not be asked in examination, but you should know this. Because in physics and chemistry, you take log. Draw a line passing through 0, 1. It goes up. Another one passing through 1, 0. This is y is equal to e raised to x. This is y is equal to log x. Draw a dot line here. This one, this is y is equal to x. Y is equal to x means 3, 0, 0, 1, 1, 2, 2, 3, 3, etc. Those. Then write some note below this. You can observe one thing. The point 0, 1. The point 0, 1. The point 0, 1 is on the graph of exponential function. Is on exponential function. You can see 0, 1 is on exponential function. The point 1, 0 The point 10 is on log function. Is on log function. See that those are remembering it before holidays. We said from the graph we can make it out the domain and range by moving a vertical, by moving this horizontal line and vertical line. Those are remembering it. See this exponential function. If you are moving this vertical line, that is value of x, you can see that this vertical line, when we take from minus infinity to infinity, everywhere this vertical line is touching this graph. So domain is set of real numbers. Whereas range for the horizontal line, range is 5 values. If we shift this horizontal line along the y-axis, you can observe it. Yes, we can observe it. This horizontal line, negative path, it is not touching. That means there are no y values in negative path. So y values start to be in positive. That's a domain and range. We discussed it before vacation. So the point 10 is on log function. Next point, the graphs of exponential and logarithmic functions. The graphs of exponential and logarithmic function are the mirror images. The mirror images of each other. The mirror images of each other. The mirror images of each other reflected in the line y is equal to x. Reflected in the line y is equal to x. Mirror images of each other. The graphs of it, yes, I repeat once again, the graph, what we said is, the graphs of exponential function and logarithmic function are the mirror images of each other. The mirror images of each other reflected on the line y is equal to x. Mirror images reflected on the line y is equal to x. See that? After drawing this graph of exponential function, if we keep a plane mirror along this y is equal to x, you can see that this is the image of this one. Similarly, if you keep a plane mirror, this is a reflecting surface, you can see these are the images of each other. Why is Ryan, what's your doubt? Why can we include y is equal to? You asked me, your doubt is, Ryan asked, can we also include y is equal to x squared? Y is equal to x squared. Yes, y is equal to x squared is an exponential function. Again, if that x squared, yes, 2 minutes, log in with the same ID. Log in with the same ID if it goes off. Y is equal to x squared is an exponential function. It is an exponential function. If the value of x is 10, it is a common exponential function. If value of x is e, it is the natural exponential function. Anyway, these are regarding the graph and function. And this graph, for examination, it may not be asked. See that, remember one more thing. This one, inverse function. These are inverse functions, in fact. The graph of inverse functions, all inverse functions, it will be the mirror image on the line y is equal to x. This you will learn in detail next year. For the time being, this is enough. Now, for our point of view, in examination point of view, these all things no problem. Even if you remember or not, doesn't make a difference. Now we'll come to questions. Questions based on functions. I think we have completed second exercise. We have completed. I think. Yes, second exercise we have completed. Now, so remember for doing third exercise, function. Function means it is relation from A to B. For all elements in A, there is one and only one image in B. That means two things we need to check. Check whether X elements are repeated. That means any X element has more than one image. Also check it, all the X elements are related. All the X elements are an image. X values are domain, Y values are range. This is the thing. So domain finding, domain and range of functions, that will be the question asked in examination. Now coming to the next exercise, it may go off within 1 minute, again log with the same ID. Coming to exercise 2.3. Which of the following relations are functions? Give reasons. If it's a function, determine its domain and range. So few functions are given. So see the first one. 2.3 first question. We have a 2-1, 5-1, 8-1, 11-1, 14-1, 17-1.